Hello and welcome back. Today we'll be doing question 5 from the 2015 MAT. This question is for all applicants. Question 5. The following functions are defined for all integers a, b and c. P of x is equal to x plus 1, m of x is equal to x minus 1, and s of x, y, z is equal to y if x is less than or equal to 0, and z if x is greater than or equal to 0. Part 1. Show that the value of this expression is 2. Let f be a function defined for all integers a and b as follows. F of a b is equal to s of b p of a, p of f of a m of b. What is the value of f of 5, 2? Part 3. Give a simple formula for the value of f of a, b for all integers a and all positive integers b, and explain why this formula holds. Part 4. Define a function g of a, b in a similar way to f, using only the functions p, m and s, so that the value of g of a, b is equal to the sum of a and b for all integers a and all integers b less than or equal to 0. Explain briefly why your function gives the correct value for all such values of a and b. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started with part 1. Firstly, we'll evaluate the first part of the big function, and that is s of p of 0, m of 0, m of m of 0. This is equivalent to s of 1, something we don't care about, and negative 2. And thus we have negative 2 as the solution for this first part of the function. Negative 2 is less than 0, meaning we don't need to evaluate the second s function, and we can simply evaluate the third nested s call. This is s of p of 0, m of 0, p of 0, and this gives us s of 1, something we don't care about, and 2, which is 2. Therefore, the entire expression is s of negative 2, 2, and something we don't care about, which evaluates to 2. Now, we'll move on to part 2. Here, we evaluate f of 5, 2, and that is equal to s of 2, something we don't care about, and p of f of 5, 1. This is equivalent to p of f of 5, 1, which we can see is equivalent to p squared of f of 5, 0, which is equivalent to p cubed of 5, which is equal to 8. From here, we can see that f is a recursive function calling itself b times, and each level adds 1 onto a when it's evaluated. This means that f of a, b would be equal to a plus b. However, notice that in the case when b is equal to 0, the return value is p of a and not a. Therefore, we have to add 1 more onto this expression, giving us f of a, b is equal to a plus b plus 1 for all positive integers b and integers a. In the case where b is less than or equal to 0, the second input to s is returned. However, we do want the case b is equal to 0 to be our base case. Therefore, we need to add 1 to b before recursively calling g. Thus, we need g of a, b to be something along lines of s of p of b, something we have not yet determined, and a. The function should also, of course, be recursive, with each layer decreasing a by 1 and increasing b by 1. Therefore, we have g of a, b is equal to s of p of b, m of g of a, p of b, and a. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.